Okay, we're going to switch now to North Greenland, to, I guess, a present-day snowball Earth, but in the 15 years I did Arctic field work, I noticed quite significant reductions in the snowfields and the ice in East Greenland and North Greenland. But what I'm going to talk about today is Sirius Passet, one of the key sites now for the Cambrian explosion. There's certainly, we know a lot about the Burgess Shale, we know a lot about Chengjiang, and we're going to hear about them. We probably don't know so much about Sirius Passet in North Greenland. Okay, so it is pretty remote. It's difficult to get to, and the collections are, for that reason, quite small compared with the hundreds of thousands of specimens from Chengjiang and the Burgess Shale. Yet, it has exceptionally preserved fossils, and it's in a very beautiful setting in North Greenland. And I think we can learn a lot more about the Cambrian explosion from this site, which we think might be the oldest. Okay, a little bit about the setting. And this is the geographic setting here in the Sirius Pass here. UP Cox Fjord runs through here, and we're just at the end. In terms of the geology, here we have the Neoproterozoic carbonates that probably nudge a little bit into the base of the Cambrian, and here we have the Buin Formation in the lower part of the Cambrian along here. As I mentioned before, it is remote. If you've got lots of money, you can take a helicopter in there, but most geologists would come in by twin otter. The first time I led an expedition there, we persuaded the Icelandic pilots, who are extremely good in these terrains, to actually land on what I thought was an old airstrip. The landing didn't go terribly well. There was a lot of bumps, and the pilots were a little bit annoyed with me. And they said, unless you do something about this airstrip, then we're not coming back to get you. And that wouldn't have been very good. So every evening we filled in all the holes in the runway, and by the time we'd finished, it was like Copenhagen International Airport. And so the pilot said, I don't know what the problem is, this is a perfect landing strip. So this was our tent, and these were our samples, and absolutely fantastic place to do field work. This is a geological setting. So it's in part of what we call the Franklinian Basin, which is a different origin from the Caledonides, which are down the east coast of Greenland. And here, the dark blue, we're in the actual trough here, in deeper water environments, and this is where the Buin Formation was actually deposited. Why is it iconic? Why should it be a site? Well, I think there's a few key points that I'll come back to. It's one of the earliest Phanerozoic Lagerstätten. It has big implications for the transition between ecosystems in the later Precambrian and the earliest Cambrian. It is a faulted contact, but here we have the pale limestones of the Portfjell Formation, upper Precambrian, probably now going into the Cambrian from recent work. And here we have the dark shales and siltstones of the Buin Formation. And this is the sort of excavation that we made on the hillside in this rather remote and beautiful area. Again, this is the locality from a different viewpoint. And there was about an hour's walk up this valley into the mountains to get to the actual site on the side of this mountain where we excavated. And this is the section that we drew up, and soft tissue preservation was very restricted to a particular zone within the sequence here that is well marked out on this stratigraphical log. And as I'll mention later, we have a lot of sort of detailed information of the range of the different taxa that we collected from this particular horizon. And what was there? Well, some of the most fantastic organisms. It's a little bit different from Chenjiang. Chenjiang has this orange matrix, and it's quite easy to see the fossils. Burgess Shale, it's relatively easy to pick them out of the actual dark mudstones. The lighting is a little bit enhanced for some of these because they're very abundant, but they're quite hard to see. And certainly in some of the forms here, once you spot the actual silicified gut contents here, then you can begin to see the outline of the whole animal. And so that's one of the key messages for anybody collecting up in that area. And sometimes when you photograph these organisms in low Arctic light, you get very good results. When you take them back to the lab, they don't look as good. A multitude of rather interesting organisms, the Vetulicolians, early chordates, we think. They're very, very abundant in the Sirius Pass. We have the frontal appendages here of an anomalocarid, and at the time, anomalocarids were thought to be exclusively apex predators. We suggested that they could also be sweep net feeders, filter feeders. The paper was rejected from about 6 journals, but eventually it was published in Nature, and now a lot of anomalocarids are thought to be suspension feeders as well as predators. We have incredible tissue preservation on Kerygmachila, for example, with the optic nerve and eyes actually preserved. And this is a current line of research now that my sort of Danish and Korean colleagues now who are working on this area are actually actively engaged with. And so I think you can see, just without going into any great detail, the huge multitude of different forms that we find in the Sirius Pass. We had models made, and perhaps the most exciting and traditional fossil that we have is Halkieria here. These were originally described from one shell in the Danish island of Bornholm, Halkieria, and then the whole animal was found by John Peel and Conway Morris at Sirius Passet. And here we have various other organisms that we thought were lobopods at the time. They have these stumpy sort of legs underneath, and things like Kerygmachila, Pamdelurian, wonderful models made by Espen Horn in Copenhagen. Where were they deposited? Well, this is a block diagram to show that they were somewhere on a gradual slope that probably extended many hundreds of kilometers across North Greenland and beyond. And there was some sort of fluid transport in which some of the carapaces were actually rolled down slope and preserved almost intact in this particular mudstone. And so we're talking about a warm, sort of muddy sea. We do have mac grounds are still preserved, which is a sort of Ediacaran type of situation, but just below storm wave base, but still within the photic zone. And this is a summary in a way. This is an artist's reconstruction of our sweep net feeding anomalocarid here, Tamisiosaurus. And here we have the frontal appendages with these fine hairs on. But basically the message is that there was a lot of life around at the time within the water column. And a lot of guys were there for these big animals to actually catch, which is probably a little bit unusual because we tend to concentrate on the benthos at this particular stage. But there's a lot of necton around in the water column. We've had Emma Hammerlund and others have been working on geochemistry, and it seems to be that we're sort of in an anoxic regime that would have aided the actual preservation. There's various indicators to show that. And there are various peaks shown by the, I think, the reactive iron, where we get the most common soft tissue preservation and where the fauna is most diverse. A little bit about the tradition. Well, there isn't a long tradition. The site was first discovered by officers of the Geological Survey of Greenland, a couple of field geologists, and they found a block of rock. And at that time, there were a lot of expeditions going and around Greenland. They were constructing maps for the whole island. And the field geologists radioed back to say that we'd found some plants in the Cambrian. This was very exciting. So they were taken back to the camp, and John Peel at the time, who was the paleontologist for the Geological Survey of Greenland, looked at these and said, well, they're actually corals. They're not plants. And he turned the slab over, and there were things that he thought were very similar to other fossils he's seen in the Burgess Shale. So these guys came back, paleontologists, and I think this is one of the first major expeditions here that my colleague Paul Smith gave me of Simon Conway Morris, Paul Schuyler, John Peel, Paul Smith, who was a postdoc at the time. And they couldn't use the runway that I precariously used. They used a better runway that was some kilometers away from the site. And so they had to heave all this gear through the frozen Arctic waters to this particular site. But they made huge collections, but mainly from the scree slopes from the actual locality itself. And so the weather wasn't very good, but nevertheless, they got a lot of publications out of this initial find. So it's been visited by only 10 collecting expeditions in some 40 years since its discovery. And my expeditions, I led them in 2009, 2011 from the Natural History Museum of Denmark. But then the Korean Polar Research Institute raised a huge amount of money, and they, in collaboration with one of my former research students, Jakob Winter, joined a group in Bristol and Copenhagen to carry out some further expeditions. So a huge amount of work is going on still on the taxonomy and phylogeny of these particular organisms. And this was my last expedition, and this was us on the slope. Another of my students here, Jakob Velu Hansen, who's heavily involved in geoheritage now, and we sat on the slope and recorded absolutely everything that we found, identified them in the field. Arthroapis here, beautiful trilobite, buonellis, and built up our rarefaction curves. The point is there's much more to be collected from this rather key locality up there. Okay, so, why is it a site? Just a few points here. Plenty of time. Okay, I'll talk slowly. Beautiful mountain setting in North Greenland. It's quite spectacular. Complete exposure, and we can see very clearly the relationship between the later Proterozoic and the earliest Cambrian and the Buin Formation over here. The fossils are absolutely superb, beautifully preserved, gut contents, guts, nervous systems, those sorts of things are beginning to appear, the different techniques that we use to have a look at these particular fossils. We've got a pretty good handle on the actual setting, environmental setting, and we've got some very nice reconstructions now of what life was like in the Cambrian. So abundant, diverse fauna, dominated by arthropods. A lot of the animals have not been transported. They probably represent a census of a living community. And it's really providing us with an insight into some of the first complex ecosystems on the planet. They were dominated by animals, and they were beginning to position themselves in a much more modern-looking food chain. And so that's my little bit of thanks at the end, but I would like to thank many people, past and present, who have worked in this very remote region. The Carlsberg Foundation, which supports a lot of science in Denmark, so keep drinking the beer. And the Danish Science Research Council, Geocenter Denmark, Agron Institute, they supported my expeditions. And as I said, the Koreans now are financially supporting a lot of the work that's continuing. So thank you very much.